Hi class, let's take a look at problem 6. Now on problem 6, we're looking at a regular sine function and they actually want us to evaluate the limit as x approaches 0 of the values of f of x. And notice that, well, on the sine function, as we get very close to 0, our function is actually defined at 0 and, well, the limit is going to be 0. So this one, it's just for show. We're using this function to take a look at a similar one, but you can see here a smooth transition in the behavior of the function as x approaches 0 from either direction. We're getting the values of 0. Now take a look at problem B. In problem B, they're asking us to evaluate the same value. So this is the limit as x approaches 0 of the values of f of x. And as the function approaches 0, you have this behavior that it's isolating. Now, let me show you with technology what it actually looks like and see if we can zoom in. Notice that your outputs are technically 1 and -1, but as we keep zooming in, the function is getting close to 0, but you're seeing this behavior that it keeps isolating back and forth, back and forth. So there's no smooth transition. As we infinitely get closer and closer to 0, our function keeps isolating back and forth from -1 to technically the values of 1. So in this case, because of this behavior, we would say that it does not exist. That's actually it. If it's asking for a justification, we could just say, well, the function isolates between -1 and 1. That's actually it for this one.